You guys want to take a look at exercise 3.15 in the book. This is a high-low problem. What is it doing for us? It's basically saying, given all of this information, all this data, what is the total cost going to be for the total items shipped for 1,000 items shipped in a month? Now, we don't have that data, all right? It's not on here, but that's going to be on a point. It's going to be on a point on our graph, all right? So if we have if this is the cost and this is the activity, if there's zero activity, there is going to be a fixed cost. All right, I'm sorry. There's going to be a fixed cost, and then there's also going to be a variable component. So fixed cost is where this intercepts at 0 on the y-axis. The variable part of this is going to be a line that increases as activity increases. So we have, two costs associated with what we're doing. Number one, what's happening when we don't produce anything? All right, where the lights are on, the people are there, but nothing's being done. You still have to absorb this fixed cost. The variable part of it comes from as activity increases. So as activity increases, there's going to be a higher cost. The people are going to be working more. The materials used is going to be higher. The direct labor associated with producing the product is going to be higher. So what we want to find is, what is the fixed cost? What's the intercept? And then we also want to find out what's the variable cost slope of this line. At what rate does the variable cost go up as activity increases? So here's how we do that. All right, we're going to use something called the high-low method. I'm sure in mathematics you've done this stuff, and some stuff is going to be familiar to you. But as we look at this chart right here, what we want to do is we want to find rise over run to find the slope. So you find the highest cost on the y-axis minus the lowest cost on the y-axis. So we have 940 is the highest, I believe, and 625 is the lowest. So let's go ahead and write that in. Let me write the formula in here for you. Total cost is going to equal fixed cost plus variable cost times the activity level. All right, so it's basically what's the fixed cost plus the variable cost times how much activity we have, or how much production we have. Let me focus this. All right, so let's go ahead and start plugging this in. So we have 940 minus 625, and then we take the activity level. In this case, it's items shipped associated with those two. So what I'm doing here is I'm taking 1200 minus 750. Those are the two activity levels associated with total shipping cost. All right, so let me write that in. 1200 minus 750. All right, and then I'll punch these numbers in. So we have, I don't know if you can see this in the light here, but 940 minus 750 equals, I'm sorry, that's the wrong, 940 minus 625 equals 315. And then 1200 minus 750 equals 450. And I believe that's going to give us 315 divided by 450 is 0.7. Okay, so that's the first part of information that we need. We're going to plug 0.70 in as our variable cost factor. Okay, so now we know one piece of information. The next piece of information we want to know is, what's our fixed cost? What's this intercept here? All right, so we're going to replug in either the highest level of activity or the lowest level of activity. Let's just do the highest here. Okay, so total cost at 12,000 units shipped is 940. All right, so 940 is going to equal fixed cost we still don't know, plus 0.70, which is our slope or our variable cost per unit, times the 1200 activity level. All right, so multiply this out. 0.7 times 1200 is 840 plus fixed cost we still don't know, 940, that's what we're solving for. 940 minus 840 is 100. That's going to equal the fixed cost part of our formula. Okay, so now we know that this is 100 plus 0.70 times the activity level equals total cost. So now we have the formula. So now what the problem in the book is asking us is this question. If we ship 1,000 units, what is the total cost? And now we have the formula set up to solve for that. So total cost is going to equal 100 fixed cost plus 0.70 times, they want to know 1,000 as the level of activity. All right, so we just go ahead and multiply this out. This is going to be 0.70 times 1,000 is 700 plus 100. So our total cost is going to equal 800. So at 1,000 units shipped, the $100 fixed cost plus the $700 variable component is going to get us to $800 total cost. All right, so that's how we would estimate total cost. And what we're doing is we're just finding a point of activity that says take that fixed cost, which is constant, and then that variable part of this, add it to it, and that will give us a total cost line, a point on that total cost line that says this is how much total cost is. All right, so that's how you execute a high-low problem of finding total cost. And again, if this was your lemonade stand, you'd say, you know, we have to set the lemonade stand up. We have to hire all the workers for the day, and even if we don't produce 1 cup of lemonade, that's going to be our fixed component to it. But as we make more lemonade, we have to multiply each unit of lemonade that we produce by some variable price, variable cost, and so that would be the 0.7. And then we could say, well, how much would it cost us to produce, let's just say, 1,000 cups of lemonade? It could get us to a total cost estimation using this regression. Okay, so I hope you learned a little bit here. Now try to execute the same problem with the problems that we get for the unit. If you need to check back to this, We'll post this on the Canvas. All right, let me know if you have any questions. Thank you.